Welcome to this new video, guys. Today I want to introduce a new format where we talk about IT, and let's start with the SQL language. SQL, Structured Query Language, is the de facto standard language for relational DBMS, which combines DDL, DML, and DCL functionality. SQL is a declarative, non-procedural language, that is, it is non-specific. The sequence of operations to be performed to obtain the result SQL is relationally complete, in the sense that every expression of relational algebra can be translated into SQL. Also, SQL does many other things. The SQL data model is based on tables rather than relationships. There may be duplicate tuple rows. In some cases, the order of the attribute columns matters. The reason is pragmatic, linked to efficiency considerations. SQL adopts the three-valued logic introduced with relational algebra. The SQL standardization process began in 1986. In 1992, the SQL2 or SQL92 standard was defined by ISO International Standards Organization and ANSI American National Standards Institute, respectively described in ISO IEC documents 9075-1992 and ANSI X 3.135-1992. The SQL 1999 standard was released in 1999, making SQL a language computationally complete and therefore with control instructions for the support for persistent objects. At present, each system still has its own dialect, largely supports SQL2. It already has elements of SQL 1999. It also has non-standard constructs. What we see is the most widespread part. The discussion of SQL is divided into several parts as follows: basic DDL and DML for algebra operators and operations of data modification, to do what is also done in algebra DML for data grouping, to derive summary information from the data DML with nested blocks, for writing complex requests, DDL for defining generic views and constraints to improve data quality, and using SQL from a guest language to write applications. The SQL DDL allows you to define relation schemas or tables, modify and delete them. It also allows you to specify constraints, both at the tuple or row level at the table level. It allows you to define new domains in addition to the default ones. For constraints and domains, you can also use the DML initially. They are not treated completely. Furthermore, views, i.e. virtual tables, and indexes can be defined. To efficiently access the data, we will see them in SILB. The create table statement defines the schema of a table, and an empty instance is created. For each attribute, the domain, a possible default value, and a possible default value must be specified any constraints. Finally, other constraints can be expressed at table level. Using the drop table statement, it is possible to eliminate the schema of a table and consequently the corresponding instance. To prohibit the presence of null values, simply impose the not null constraint. For each attribute, it is also possible to specify a default value, which will be used if it is not provided when inserting a tuple. Explicitly, a value for the relevant attribute. The definition of a key occurs by expressing a unique constraint, which you can specify inline whether the key consists of a single attribute, or after declaring all the attributes whether the key consists of one or more attributes. Now let's talk about the definition of keys. The primary key of a table is defined by specifying a primary key constraint, either inline or as a table constraint. Imp cod char4, primary key cod prog city. It should be noted that specifying a primary key is not required. You can specify a maximum of one primary key per table. It is not necessary to specify not null for the primary attributes. The definition of a foreign key occurs by specifying a constraint foreign key and indicating which key is being referenced. Site, that is to say, char3 foreign key headquarters. References, locations, headquarters, references, locations, headquarters. In the example, imp is called the reference table and sedi is called the table of destination, similar terminology for the attributes involved. The target columns must be a table key destination, not necessarily the primary key. If you omit the destination attributes, those of the destination are assumed primary key site char, 3 references locations. Using the check clause, it is possible to express arbitrary tuple constraints, exploiting all the expressive power of SQL. The syntax is check n. The constraint is violated if there is at least one tuple that makes the false. Therefore, internal salary check salary greater than 0 does not allow tuples with negative salary but allows null values for the salary attribute. If check is expressed at the table level rather than in the definition of the attribute, it is possible to refer to multiple attributes of the table itself. For diagnostic and documentation purposes, it is often useful to know which constraint was violated following an action on the DB. For this purpose, it is possible to associate names with the constraints, for example, internal salary constraint, salary positive check, salary greater than 0. Using the alter table statement, it is possible to modify the schema table, in particular, adding attributes, adding or removing constraints, alter table set, add column sexchar, 1 check sex in M, F, ADD constraint, salary max, check salary 4000, drop constraint, salary positive drop unique, surname name. If you add an attribute with not null constraint, you must provide a default value which the system will automatically assign to all tuples already present, ADD column instruction char 10, not null default graduation. The main SQL DML statements are select, insert, delete, update, executes queries. Queries on the DB inserts new tuples into the DB, delete tuples from DB, modify DB tuples. Insert can use the result of a query to perform insertions. Multiple delete and update can make use of conditions to specify the tuples to delete or modify. It is the instruction that allows you to execute queries on the DB. The basic form is select a 1, a 2, AM from R1, R2, Rn where. That is to say, select or target, list from clause. Where, clause, what do you want as a result? Where do you get it from? What conditions must it satisfy? The select statement does not allow you to perform union, intersection, and difference of tables. What you can do is combine the results of two appropriately select statements using operators union, intersect, except. In all cases, the elements of the select list must have compatible types, the same names if you want columns with a defined header. The order of the elements is important, positional notation. N, the result is in any case free of duplicates. It is necessary to maintain them, add the all option, union all, intersect all, except all. You can insert a new tuple by specifying its values. Insert into locations, headquarters, manager, city, values, S04, Bruni, Florence. There must be correspondence between attributes and values. The list of attributes can be omitted, in which case the order in which applies have been defined. If the list does not include all the attributes, the remaining ones take on a null value, if allowed, or the default value, if specified. Insert into locations, headquarters, city, headquarters without manager values, S04, Florence. I hope you enjoy this video for today and all. If you want other videos like this related to IT, I'll show you everything. Next week we would do the second part. See you soon.